Tolerances state how accurately a feature needs to be made. They also define what is and what is not acceptable. They are not the same as dimensions, although dimensions can suggest tolerances. Sometimes on a print you'll see something like this that state general tolerances. You'll notice based on the number of decimal places the dimension has, the tolerances change. However, this is not going to be sufficient for all parts. Let's take a quick look at a common item, a wheelbarrow, and specifically the wheel on the wheelbarrow. Some dimensions of the wheel must be controlled very tightly, others can vary more. Let's look at the width. There's quite a gap on each side, over an inch. This could be quite a bit wider or narrower without affecting the form, fit, or function. The same is true of the diameter. The diameter could be more or less. However, if we look at the bore, there is a bearing in here, and the bore must be controlled very accurately so that that bearing will actually fit and not fall out. The diameter of the bore needs a much tighter tolerance than the diameter of the wheel or its width. Here's a sample print. It's not fully dimensioned, but has a few examples. Let's first look at a symmetrical tolerance, the thickness of this web. Notice that it has a plus or minus 0.2 tolerance. This means it could be as large as 2.2 or as small as 1.8. Next, let's look at the diameter of the bore. The diameter of the bore is controlled by a unilateral tolerance. This means it can only go in one direction. In this case, it can be 1/1000th smaller, but not any larger. This ensures the bearing will fit snugly in the bore. Finally, we have limit dimensions. The limit dimensions specify the maximum and minimum sizes. These could be symmetrical or not, but it allows us to see the range in which the dimension can vary. There is one more dimension on this part that doesn't have a tolerance, but does have an additional number. And this dimension over here has the alternate unit of millimeters attached to it.